Hello students, this discussion is about Ampere's law. Ampere's law is also called Ampere's circuital law. Ampere's circuital law. Circuital law. So just I have taken the statement, just for understanding I have pasted some information. So Ampere's law states that the line integral, it's a line integral of magnetic field around any closed path. Line integral of magnetic field around any closed path. Okay. So any closed path is taken and that is called what? The closed path is what? Amperian loop. So is equal to the permeability of free space times permeability of free space times. So by the total net electric field, electric current enclosed by the loop. Okay, it serves as a magnetic analog to the Gauss law in electrostatics, which means, so here just I am talking about this closed integration over, okay, closed integration over B bar dot dl bar line integral. Okay, so B bar dot dl bar is equals to mu naught, okay, permeability of free space into times of net current enclosed. So net current enclosed. Closed integration over B bar dot dl bar is equals to mu naught times of I enclosed or I net. So for example, if you choose any closed one, for example, these are the sum of currents. This is I1, next one is what? I2, okay, next I3, like this if you take about, this is what? I3. So this is the closed loop, okay, it's a closed loop. Net enclosed currents in the given loop, okay, given region. This you can understand this. If you want to take, you can take from this one also. So which is subjected, that we have to concentrate it. So and what is the length element? The field is what, like this is the field, it's a dl bar, okay, it's a field is the dl bar. So dl bar is, this is the dl bar, and next one is that its magnetic field is what? It's the length element, this is the length element is taken is here. And next one is direction of magnetic field is what? dB, otherwise B. So the angle between these two is what? Is a theta is equals to, we can say 0 degrees. Okay. So that what I am trying to say here. Now Ampere's law, closed integration over B bar dot dl bar is equals to mu naught times I enclosed. So closed integration over BDL. So this is what closed integration written. B dl cos theta is equals to mu naught times of I enclosed. Okay, it's a enclosed current. So now we can see this. So closed integration over B dl cos theta. What is the theta? Theta is angle between. First one is what? Length element is dl bar and magnetic field, which is very, very important. Okay. So by using this Ampere's law, we can calculate the relation between, okay, so first exactly what the exact magnetic field of a given region, and next one is that, so any inside the solid wire, okay, and a hollow cylinder, okay, and next one solid cylinder. So inside and outside the ratios of magnetic fields, all these can be calculated by using Ampere's law. Okay. So from this Ampere's law, first one I am taking as case wise, it's a first case one I am taking this. This case one is, I am taking as what? It's a straight wire, current carrying wire. Okay. Let it be, this current is what? I want to find this magnetic field at this point. Okay. So it is what? Just imagine it's a infinite length. Is infinite length. So for the infinite length, this is perpendicular distance from here. So what is the perpendicular distance? R. At this point magnetic field is what? Right hand thumb rule. The thumb is towards here and it is what? into the plane. It's a into the plane. So then how do you get the magnetic field here? So this magnetic field is what? Mu naught I by 2 pi r. Usually we calculated in earlier sessions. But by using Ampere's law, how do you calculate this? Okay, so by this one is that imaginary surface we have to draw it while enclosing this. This is called Amperian surface. Say Amperian surface. So for the Amperian surface is this. And next one, if you choose about this part is what you say, it's a length element. So what is the length element? It's a dl. Okay, and next one is the magnetic field is what? It's a tangent drawn to the surface. What is that? Circle around this one, tangent drawn, that gives what? B. What is the angle between these two? Theta is equals to what you say? 0 degrees. So I want to find the magnetic field at this point by using what is the formula? Ampere's law. So what is the Ampere's law? Then what? B, close integration over B dl is equals to mu naught times I enclosed. So B integration over dl is what? L is equals to mu naught times. So I enclosed is what? What is the current enclosed in the given Amperian surface? What is this? This is the current is I. So I we can write B into what is the L? Length element. Length element dl, dl, dl and all those if you take it as. So what will be the value? 2 pi r is equals to mu naught times of I. B is equals to mu naught I by 2 pi r is the relation, and direction we can give it is what? Into the plane. So what I am trying to say here, from this one Ampere's law, by using Ampere's law I have taken a wire. For the infinite wire I calculated, first thing is what? Where you want to find, there you draw imaginary surface. That imaginary surface is what you say, it's an Amperian surface, and how many currents are enclosed into inside through this one is what? I. And next one, what is the net magnetic field? So B is equals to mu naught I by 2 pi r. What is the magnetic field due to hollow cylinder? So first you take about this one. Very first case is what? So in this one is hollow cylinder is taken. This is the hollow cylinder. Okay, like it's a cross section. Infinite, it's a infinite. So like this, it's a infinite. Yes. Now, so this is the axis of this cylinder. Yes. Its radius is capital letter R. First one. So very first case is what? Case in a Roman number 1. X is less than R. X is less than R. X is less than R means what? Inside or outside? It's a inside. This is inside. Okay. So you choose about this is the point where which is less than R. Draw the Amperian surface. Yes, Amperian surface is drawn like this one. So the current through this one is what? 3. You can observe this one. Current through this on the surface means what? Here. Okay, means on the surface only. So current passing through this surface is what you say, it's a I. You don't say how many I are there, those, not like this. Only on the surface is taken. So it's a, what is the net current here? I. Okay, so what is the inside of this one? Current is what? I enclosed. This is what you say, it's a Amperian surface. Okay, it's a Amperian surface. In Amperian surface, so what is the current here? I is equals to what? 0. Yes, because inside no current. Now I enclosed is equals to what? You got it. I enclosed is equals to 0. Now apply the Ampere's law. Closed integration over B. Okay, B. dl is what? dl. Okay, B dl means what? It's a L is equals to mu naught times I enclosed is what? 0. Then B inside is equals to what you say? 0. So what is the magnetic field inside the hollow cylinder? It's what? 0. So next one is for second. I am taking this second. So what is this? X is equals to R. X is equals to R here. So again draw the cylinder. Okay, it's very simple by using Ampere's law. So again draw the cylinder. So this is the axis of the cylinder. This is what it's a R. Okay, here I want to find it. Where this? So what is the current again here? Current is what? I. Okay, so current is what? Total current on the surfaces. Okay, it's what? I. And next one is here. In this case, it's what you say. This is what its radius is r. Okay, so at this point, this is the Amperian surface. Okay, in this Amperian surface, what current is here? Same current. So that means what you say? It's a current is what? I only on the surface total. Okay, like this one, correct? So I enclosed is equals to I. Now you apply. So what is this? Ampere's law. B times of L means what you say, it's a 2 pi R is equals to mu naught times it's a I. So B is equals to mu naught I by R is the relation. So what is the magnetic field on the surface? B is equals to mu naught I by R. So next I am taking about, it's a third one. Outside X is greater than R. X is greater than R means what? This. Okay. Next. So again I am taking as, here is the infinite hollow cylinder. This is the axis. Okay. It's what? Axis. So its radius is R. I am choosing at this point. So at this point means what? Draw the Amperian surface. So what is the distance from here to here? X. Okay, X is what? Greater than R. So here, what is the distance here? X only. But X is equals to what you say? R. So that's what we proved here. So next one, here X is at this point I want to find the field. X is greater than R. Okay. So now I enclosed is equals to what? I enclosed. You can see this one. This is the enclosed part. Inside this, what current is there? Only one current, that is what? I. Okay, I enclosed is equals to I. So now, how do you write this one? B times of L means what? Again 2 pi R. R means what? X. Here 2 pi R. R means what? R only in place of X, R. So here nothing is required. That's what I didn't write. Okay, this is equals to mu naught times of I. So B is equals to mu naught I by 2 pi X. The relation, the magnetic field. Okay, so magnetic field outside. So this we can write it as B is inversely proportional to X. B is inversely proportional to X. So now graphically, if you see this one, this is what? Here is the graph. It's the magnetic field, and this is the X. Till X is equals to R, nothing. Till X is equals to R, so no field. Okay, till X is equals to R, inside 0. So here is the maximum. So what is the maximum here? This. Okay. Then after that, it is inversely proportional. Means what? B inversely proportional to R, or B inversely proportional to small r. Anyone we can write it. So what is the maximum value? This one. This is what? Mu naught I by R is the relation. So this is for hollow cylinder. So hollow cylinder inside, next one on the surface, and next one is outside also we can write it. And this is the related graph. So definitely every time its applications are repeating. Next I am discussing about solid cylinder. Okay. So magnetic field due to solid cylinder. How do you calculate the magnetic field to solid cylinder? So for the solid cylinder, current density we have to use it. Current density is what? J. J is equals to I by A. Okay, it's I by A. So solid cylinder, when you talk about this one, current density we have to remember. So current density is J. Okay, so J is equals to I by A. The J is I by A. A means what? It's a cross sectional area through current is passing. So first one, very first case again, same like earlier what we written. So first one, X is less than R, means what? Inside. Draw the solid cylinder. Okay, here is what? It's a solid cylinder. Solid cylinder means what? the current is passing through its diameter like this. And we can observe this. What? I. Okay. So here is the axis. This is the axis. Now where you want to find? I want to find at this position. X is less than R. Then how should I take it? It is a Gaussian, what is a Amperian surface? The Amperian surface. So this current is I. So what is this current? It's a, let it be I dash. This current is what? I dash. Okay. Now, so what? How to use this one? Ampere's law. B into, okay, L is equals to mu naught times of I enclosed. Enclosed means what? I dash. B into L means what, beta? This part is what you say, it's a X, let it be. So this is what? Pi X. 2 pi X is equals to mu naught times, what is this? It's a I dash. Now the question, how do you calculate I dash from this? So my keyword is what? J is equals to I by A. So I can write this one, J is equals to I by A means what? For complete one, pi R square is equals to I dash by pi X square. Okay, pi and pi cancel. I dash is equals to, so what do you say? I dash equal to X square by R square, correct, into I is the I dash. Now we can write this one from here. Yes, so this is what? B into 2 pi X is equals to mu naught times, so I dash means what you say? It's a X square by R square into I. Okay, so X and X cancel. Then B is equals to what? You write mu naught I by 2 pi, okay, R square into X, which is very, very important relation. So mostly many questions are there, PYQs in all the levels. B is equals to mu naught I by 2 pi R square into X, which means what? B is directly proportional to X. B is directly proportional to X. Means from year to year, if I take it as X equal to 0, at this point magnetic field is 0. So from year to year, gradually when you are moving away from this towards the surface, at the surface the field is what? Maximum. Okay, at the surface field is maximum. Okay, so B is directly proportional to X. And next one, for the second one I am talking on this, it's a X is equals to R. X is equals to R means what? On the surface. X is equals to R means on the surface. So then B is equals to, we can write mu naught I by 2 pi R square into X. X means what? It's a R. R cancel. B is equals to mu naught I by 2 pi R, which is maximum field on the surface. Maximum field on the surface. So next one is what? Here for the third one I am talking on this. For the third one. So what is the third one? It's a X is greater than R. X is greater than R. So then what? How do you take this one? I have taken as a cylinder. Okay. Same the region like this is the axis. This is what it's a R. I want to know at this position. Where? So this is what? Amperian surface. Amperian surface. So this is what? X. This is X. X is greater than R. Okay. So then how do you write the formula? How do you write its formula? Okay. So I can write the formula on this. So B into 2 pi. R means what, beta? R means what? It's a, this is X is equals to mu naught times of I. I enclosed is what? What is the current enclosed here? I only, because here this total is a surface. From this surface only, this is what? One portion. So that current carries what? It's a I. Mu naught times of I. P is equals to mu naught I by 2 pi X. Okay. So this is the outside. So if you want to take it as, this is B inside, you can write it as, it's a B inside. So this is on surface. So on the surface, and this is what B outside, we can write it. Okay. So if you draw the graph on this one, this is, so it's B, this is what? X. So the graph will be what? From year to year directly proportional till where X is equals to R. After that, it reaches to the maximum value. So this is what? Inversely proportional. So the graph shape is what? This. Okay? B proportional to X. This is B inversely proportional to X is the relation.